In today's lesson, we are going to talk about indicators. Indicators are dyes that exhibit different colors in acidic and basic solutions. An indicator is a weak acid that changes color with changes in pH. In aqueous solution, the acid form of the indicator, represented by HIN, is in equilibrium with its conjugate base, ion negative, and vice versa. These two forms will exhibit different colors. This is the equilibrium expression for a general indicator, where HIN represents the weak acid, so the H in the front indicates that it's acid, IN meaning indicator. We always add that to water, use equilibrium arrows to produce hydronium and the conjugate base of the indicator, IN negative. You will be asked on the worksheet to produce equilibrium expressions for particular indicators, so please keep this in mind. If we take an indicator and we add it to a strong acid solution, the hydronium ion concentration will increase, and therefore, according to Le Chatelier's principle, the equilibrium will shift to oppose this change, so it will shift to the left, and the color of the solution will be the color of the indicator in acid form. Conversely, if we take an indicator and we place it in a basic solution, it means that the equilibrium concentration of hydronium will decrease. Therefore, according to Le Chatelier's principle, the equilibrium will shift to oppose this change, and therefore it will shift right. At this time, the indicator will have the color of that of its conjugate base. There is an array of indicators that one can choose from, and you need to choose an indicator with the pH range that includes the pH at the equivalence point. In previous lessons, we have went through how to predict what the pH will be if we have a titration with a strong acid and a strong base, a strong acid and a weak base, or a weak acid and a strong base. There is a list of indicators for this course that will be provided to you, and they are found at the bottom of the acids and bases strengths table. If you look at your acids and bases strengths table in your chemistry data booklet, you will notice at the bottom of the page there is a list of acid-base indicators. They start at methyl violet and go all the way to 1,3,5-trinitrobenzene. You'll also notice that next to the indicator name is the pH range. The pH range indicates the range in which the indicator will change color. Therefore, it's the pH range that indicates when this indicator will work, and you need to match it up to the equivalence point of the particular titration that you are performing. You'll also notice a column for color change as pH increases. If we take a look at, for instance, methyl red. Methyl red has a pH range of 4.8 to 6.0. So you will choose methyl red as an indicator when your titration has an equivalence point that falls between 4.8 and 6.0. To match this up to the color change, methyl red anywhere from 0 all the way up to 4.8 will remain red. So if I was to put this in an acidic solution that had a pH of less than 4.8, the solution will turn red. Between 4.8 and 6.0 in its equivalence point, methyl red will be a combination of red and yellow, or it will appear orange. As you continue to add base to this titration, as it moves past 6.0 all the way to 14, it will only be yellow. Therefore, if I start with a solution that's very low in acidity, and using methyl red as an indicator, it will appear red. As I get closer and closer to the equivalence point, and I actually reach the equivalence point between 4.8 and 6, it will be orange. And from 6.0 on to 14, it will look only yellow. This is how you read the acid-base indicators table. Let's look at an example of a titration between a strong acid and a strong base. We know from previous lessons that the pH at equivalence point will be 7. So let's look for some indicators that would work in this titration. Again, for the example, we're looking for some indicators that will work on a titration between a strong acid and a strong base that has an equivalence point at 7. Methyl violet only works between 0 and 1.6, so this will not work. Thymol blue will only work between 1.2 and 2.8, 8 and 9.6, which does not fall in the 7 range, so thymol blue will not work. Orange 4 has an equivalence point indicator of 1.7 to 2.8, that does not work. Methyl orange doesn't work, bromo cresyl green does not work. Litmus has a range of 4.5 to 8.3, and 7 falls between here, so litmus will work. Methyl red does not work in this case, it only has a range of 4.8 to 6. Chlorophenol red does not work with a range of 5.2 to 6.8. 7 does fall between 6 and 7.6, so bromothymol blue will work. 7 also falls between 6.6 and 8, so phenol red would also be a suitable indicator to use in this titration. 7 does not fall within the rest of the possible indicators on our list. Therefore, we have 3 different choices that would work. We could use litmus or litmus paper. We can add bromothymol blue, or we could also add phenol red, and these indicators will work in a titration between a strong acid and a strong base. I now encourage you to go ahead and try the indicators worksheet. Remember that the answers to this worksheet have already been posted.